Hello student. Yeah, in the last class we are going to discuss with the lesson of the atoms and molecules. In that we discuss about the so many concepts regarding about what is atom, who give the contribution for writing the atoms, and also we discussed that how we are going to write the atoms by using the sum of the symbols. By using the sum of the symbols, how we are going to write the atoms. Now, we again continue with the chapter that we are going to write the atoms or write the elements now by the use of the IUPAC. Now we are going to discuss with how we are going to write the symbols for the element by the use of the IUPAC. What is this IUPAC? What is the full form of the IUPAC? What are the rules that given by the IUPAC to write the symbols of the element? If you see that, what is exactly that IUPAC means? International Union Pure and Applied Chemistry. IUPAC. What is this IUPAC represent? IUPAC represents that International Union Pure and Applied Chemistry. This committee tells how we are going to write the elements. If you see, before the days, we just tell the element symbol by the use of their respective where it is present from their sources. If you see the acetic acid, okay, the acetic acid is obtained from the vinegar. Okay, acetic acid is obtained from the vinegar. The vinegar is nothing but the acetic acid. We just give the name from where the source, from where we get that element. But nowadays it is not like that. With the use of the IUPAC, we are going to name the elements now. If I ask that, just tell the symbol of the hydrogen means you will tell H, oxygen O, sulfur S, copper Cu, magnesium Mg. Like that you are telling, right? How you are going to tell these symbols for the element? Okay, there are certain rules that given by the IUPAC to write the symbols of the element. The first important rule for writing the elements are, the first one, we want to take the first letter of the element to write the symbol. This is the first rule. What is the first rule? We want to take the first letter. We want to take the first letter of an element. That also should be in the capital. That is the first rule. We want to take the first letter of the element. That should also be the capital. Shall we see some of the examples? Okay, the first element of the periodic table, hydrogen. If you see the hydrogen, we take the first letter of the hydrogen and we make the symbol of the hydrogen is H. After that, oxygen, the first letter O, carbon C, fluorine F. Like that, we are going to take the first letter of the element to make the symbol. After that, after writing some of the symbols for the element, next there is a confusion happens. What is that confusion means? If you see for the nitrogen also, the first letter is N. If you see the next one, neon. Okay, if you see the element neon, that also start with the N. Nitrogen also N, neon also N. Then how we are going to write the symbols? How we are going to write the symbols? Then the next rule for writing the symbols came. What is this next rule? The next rule says that we want to take the starting two elements, which are the elements having the same starting letter. Then in that element, we are going to take the starting two letters. I said that one is the nitrogen, N is there, and the neon also, N is there. In that, for the nitrogen, we already know, that's why the nitrogen already N is written. After that, if any element have the respective same letters, then we want to take the next second letter. We want to take the second letter of the element with the small letter. The first letter should be the capital and the second letter should be the small. Therefore, if you see that the nitrogen and the neon, the nitrogen, the symbol is capital N. And if you see the symbol for the neon is capital N along with small e. N-E-O-N, neon. First, we want to take the two letters. The first one should be the capital and second one should be the small. Shall we see some other examples? If you see some other examples for this type, that means this rules, the second one is carbon and calcium. If you see the carbon and calcium, carbon is also start from the C, the first letter, and also the calcium is also start from the letter C. Therefore, here the second rule implies. Therefore, what may be the symbol of the calcium? Ca. Capital C, small a. Therefore, the symbol of the calcium is capital C, small a. And also if you see the another symbols of that, copper, Cu. You can tell that, ma'am, here the copper CO, PPER. If you want to tell that you want to take the two letters means, we want to write it as CO. If you see, we can't write here as the CO. Why means, already for the cobalt, the symbol is CO. Therefore, we can't again give the symbol for the copper is CO. Then how we get this Cu? I said that in the previous concept, that means before the IUPAC exists, V represents the element by their source. Therefore, the copper is the source of the cuprate. Cuprate. We just take the two letters from the cuprate. That is Cu. Therefore, the symbol of the copper is Cu, not CO. Understood? Again, barium, Ba, calcium, Ca, zinc. You can tell that here also, zinc, ma'am, Zi. Why you written Zn? If you see, for the zinc, already for the zirconium, Zi is there. Therefore, we can't again give the Zi. Therefore, the third rule, if the first letter is also, the first two letters is also present means, we can go for the first and the third letter. If first two letters, the first starting two letters is already present means, we can leave this second letter, we can go for the third letter. Therefore, the first and the third letter can also be made as a symbol. This is how we are going to write the symbols for the element. Now I am asked some of the elements you want to tell the symbols. First element, magnesium. Second one, aluminium. Third, potassium. 4th, rubidium. 5th, neon. 6th, that means chlorine. Next, oxygen. Next, sodium. Okay. After discussing this all the elements and their symbols, now we are going to discuss with the next concept, that is of the atomic mass. This concept of the atomic mass, atomic number, we already discussed, right? This atomic number, the total number of the protons that present in the atom is called as an atomic number. This atomic number, the total number of the proton that present in the atom, we call it as an atomic number. Then what is this atomic mass? The total number of the proton and the neutron that present in the atom, or otherwise we can call it as the total number of the proton and neutron present in the nucleus. We call it as an atomic mass. Understood? See some of the example. If you see some of the example, for the carbon, if you see the carbon, the atomic number of the carbon is 6. Then the atomic mass of the carbon is 12. Don't think that, ma'am, if you just multiply with 2, you will get the atomic mass. No, not like that. It depends upon how much of the neutron is present. Okay. Okay, next example. If you see, the atomic number of the nitrogen is 7 and its atomic mass is 14. And also if you see the chlorine, 17, but its atomic number is, atomic mass is 35.5. Okay. This is how we are going to find out the atomic mass. After that, after studying the atomic mass, next we are going to discuss about the molecules. What are molecules? If one or two atoms combine each other to form the molecules. What are molecules? If two or more atoms combine each other to form the molecules. In the molecules, if you see the molecules, the concept, if you come for this one, the molecules, you already know the definition of molecules, right? What are molecules? If one or two atoms combine each other to form the molecules. In that molecular concept, we want to discuss about the molecules of element. What is this molecules of element? Consider if the identical elements are mixed. That means if the identical element, if the atoms are mixed, then that type of the molecules are called molecules of an element. If you want to study the molecules of an element, we want to know that the definition of the atomicity. This is the important definition, that is atomicity. What is the important definition, the atomicity? Can you anyone tell the definition of the atomicity? Okay, I will only tell that. What is atomicity means? It is defined as the number of atoms that present in an element. Monoatomic, diatomic, triatomic, polyatomic. What ma'am is telling? Mono, di, tri, poly. We don't understand. Now we will study one by one. I said that what is atomicity? The number of atoms that present in the elements, we call it as an atomicity. Take the example hydrogen. Hydrogen, okay? H2. This is an diatomic. How I call it as an hydrogen H2 and a diatomic? If you see the hydrogen, H2 is the formula, right? Hydrogen. If you see the hydrogen, 2 hydrogen is present. Therefore, 2 molecules of the hydrogen is present. Therefore, 2 indicates the diatomic. And also if you see the oxygen, oxygen is also the diatomic. If you see the ozone, O3, Therefore, it is triatomic. Can you give such examples now? For the diatomic, triatomic and polyatomic? You can give so many examples. Fluorine, Cl2, fluorine, F, monatomic, sulfur, S, oxygen, O2, helium, He. If you see, the one thing means all the elements can maybe, some of the elements can maybe diatomic, triatomic like that. But the noble gases always be the monatomic. Okay, always the noble gases should be in the monoatomic. Can you tell what are the noble gases? We have helium, neon, krypton, argon, xenon, radon. These are the important 6 noble gases. These 6 noble gases are monoatomic. That means it consists of only the one atom. Which are the 6 important noble gases? Helium, neon, argon, krypton, xenon and radon. After studying the concept of the molecules of the element, now we are going to discuss with the molecules of the compound. What is this concept? Here the molecules of the element, here the molecules of the compound. If you see, here the same elements are combined each other to form the molecules. Here the different elements are combined each other to form the compounds. What is the molecules of the compound? If you see, the two different elements are combined each other to form the compounds, then we call it as in molecules of compound. If you see the example for the compounds, best one is the water. What is the formula of water? H2O, right? What are the elements that are present in the water? One is hydrogen and another one is the oxygen, right? These are the 2 elements that present in the water. If you see, what is the atomic number? What is the atomic number of the hydrogen? 1. And what is the atomic number of the oxygen? 8. Therefore, its ratio is, the ratio of the presence of the element in the compound is 1:8. How much? 1:8. Hydrogen is 1 and oxygen is 8. If you see the ammonia, what is the formula of ammonia? I didn't written here. What is the formula of ammonia? NH3, right? Nitrogen and hydrogen is present. One is nitrogen is present and hydrogen is present. Nitrogen and hydrogen is present in the ammonia. If you see, what is the atomic number of the nitrogen? 7. What is the atomic number of the hydrogen? 1. Therefore, its ratio of the compound, is 7:1. 7:1 is the ratio of the ammonia. Okay. After that, if you see, the next concept is of the ions. What are these ions? Can anyone tell that what is the definitions of the ions? Can anyone tell what is the definitions of the ions? Okay, consider that the metals and non-metals are combine each other, right? Metals and non-metals are combine each other to form the charged species. Metals and non-metals are combined each other. Metals and non-metals are combined each other to form charged species. That charged species we call it as an ions. Metals and non-metals. Metals and non-metals are combined each other to form the charged species. That charged species we call it as an ions. Best examples, if you see, sodium chloride. If you see, sodium is the metal, chlorine is the non-metal, chloride is the non-metal. Here, this sodium and chloride are combined each other to form a charged species. That is, if you see, for the sodium, what is the charge? It consists of positive charge and chlorine consists of the negative charge. What are ions? When a metal and a non-metals are react each other to form the charged species. We call it this as an ions. Here also, if you see in the potassium chloride also, potassium plus and chloride minus. And next, we are going to discuss with the next important concept, that is how we are going to write the formula for the compounds. How we are going to write the formula for the compounds. For writing the formula, the main three important things you want to know. One is the symbol of the elements. The first main concept is you want to know is the symbol of the elements. Second one, valency of the element. And the third one, how you are going to intercross and you can write the formula for the elements. These are the concepts we want to study in the next class. In the next class, we are going to discuss with how we are going to write the formula for a compound. Up to that, bye everyone and thank you.